In this video, we are going to solve some integration by substitution questions. Now, this is a key concept which students typically find pretty tricky, these types of questions. So I'll go through 3 examples, and hopefully by the end of them, you'll be very confident in this topic. Okay, so when do we use integration by substitution? It's when we want to integrate something that looks pretty complicated. All of our integrals so far don't typically have fractions where there's x's on top and bottom, or there's x's here and here, or there's x's inside root signs. So if there are x's that are appearing in multiple places in your function and we need to integrate it, it's most likely integration by substitution. Now the first step, I'll start with question 1, is to try and identify a parent function. And by parent, I mean there needs to also be a child in the function, and the child will be the derivative of the parent. So in this case here, x squared minus 3, if this is the parent, is there a derivative that's also in the question? Well, it is. The derivative of x squared minus 3 is 2x, and that's also here. So once you've identified the parent, that's the first step. You need to say u equals the parent, x squared minus 3. Now that's probably the first step and probably the hardest step in this process. Once you've identified that, the rest of the question isn't too bad. Next, we need to take u and find the derivative. And we want to write it as du dx. We're going to derive this u here in terms of x, which will be 2x. And then from this step, there's actually a few ways you can do integration by substitution. I'm going to show you the method that I currently use, and I think it's pretty simple. What you want to do is you want to get dx to be by itself. And it's always going to be the same process in this step. You multiply the dx up here, and you divide whatever's here down. So we're going to get du on 2x equals dx. I've just multiplied the dx up, and I've divided the 2x down. Okay, so we've identified the parent, we let that equal u, we derived it, and then we made dx the subject. Then we go back to our question, and we rewrite our integral, and we always put a divided by sign. Okay, 2x, I'm just going to write 2x in, and what I'm going to do is just replace my parent function, x squared minus 3, with the letter u. I've substituted u in. Integration by substitution. And then instead of writing dx, which will be on our numerator here, I'm also going to substitute in what we know dx is also equal to, du on 2x. That's the same as dx. So from here, what will always happen is you'll get these x terms cancelling out, and you shouldn't have any x's left over once you've correctly substituted in. So the 2x will cancel out with a 2x. And there's just a 1 now, so the integral that we're left with is just 1 on u du. And just remember, this dx and this du, this is just attached to any integral. It means we need to integrate that letter. So when we're at this stage here, we're just going to now integrate 1 on u in terms of u, and the integral of 1 on u is just ln u, using our integral knowledge, plus c. Now this is our integral. And then to our final step, we can't leave our answer with u in there because u was just a tool letter that we used. Let's replace u with what it originally was, x squared minus 3 plus c. And this is our answer. So a quick summary, parent function is u, we derive it, we get dx to be the subject, then we replace u and dx. We'll have a new integral now just in terms of u, we integrate that, and then we sub in back in our u value. Okay, let's try another example. If we can identify here a parent, which will be x cubed minus 1, the derivative of this will be 3x squared, and that's also in the question, kind of. It's just out by a scalar, out by a factor, which is okay. So once we've identified the parent, u is x cubed minus 1, we derive the parent, du dx will be 3x squared. We get dx to be the subject, so du on 3x squared will be dx. And now we're ready to substitute everything in. So we rewrite our integral, always with a division sign. 6x squared, I'll just leave this as 6x squared. This is now u, so u to the power of 4. Notice if you ever have a parent inside a bracket to a power, we don't consider that in the parent here, we just consider the x cubed minus 1, and we'll power the u. Okay, and dx we can replace with du on 3x squared. Now, similar to example 1, our x's should always cancel out, and x squared will cancel out with x squared, and 6 cancels out with 3, just to become the integral of 2u to the 4 du. Now from here, if we want to integrate, it will just be 2u to the 5 on 5 plus c. This is just our basic integration step. And then finally, we need to replace u, so 2, and then u was x cubed minus 1 to the 5 on 5 plus c. And that's our answer. So once you get the hang of this, it's actually not too bad. It stays the same, really, for all of these integration by substitution questions. This last one's a bit of a trickier one. So hopefully we are good now at spotting what the parent will be. The parent u, in this case, will be x squared plus 3. X squared plus 3. We then find du dx, which will be 2x. Then we get dx by itself by multiplying it up and dividing the 2x down. So du on 2x will be dx. Next is our substitution step. So we have an x on the top, we have root, and this will be u, and then dx is du on 2x. Our x's should always cancel out. So we're left with the integral of, there's a 1 here, once we cancel them out, it'll be 1 on 2 root u du. And this is just a integration where we need to use our indice laws. This is the integral of, now the 1 and the 2 need to stay there, but the root u, this is the same as u to the half, u to the power of a half on the denominator, which is also the same as u to the negative a half on the numerator. That's our indice laws. So u to the negative a half over 2. So I didn't integrate in this step, I just used my indice laws to bring the root u up. If we were to integrate this, we raise the power by 1, so u to the negative a half will become u to the positive a half over, and the new power comes down and multiplies by the 2. A half times 2 is just 1, so plus c, and therefore our answer will be u to the half, which is the same as the square root of u, which will be the square root of x squared plus 3 plus c. Okay, so well done if you managed to track that. There are a few different ways to do integration by substitution, so you may see a video where in this step here, they might slightly change the order and the way they do things, but what this whole topic is doing is we are taking a complicated integral and we are using a different letter, and that helps us simplify the integral, and we're using that letter to substitute it in, and that helps us integrate a complex function and get our answer. Okay. Good luck practicing these types of questions.